Welcome to video number 14, and video 14 is number 4 on the iteration playlist, and this one is dedicated to iteration with flowcharts. So guys, the purpose of this video specifically is for you to understand how flowcharts can be used to present the structure of loops and the sequence of code. As always guys, the Python Monster resources are there for you to supplement your learning from the classroom. That includes the booklets and these videos, of course. You may also find those useful for revision as well. So from the perspective of your GCSE computer science guys, it is quite important that you are comfortable and confident being able to create and interpret flowcharts, not just for condition and selection, so that's the if-else statements that we've looked at previously, but also for iteration as well. And just like condition and selection, iteration does lend itself very well to the visual representation of sequencing of code using those flowcharts. So what I'm going to do is something similar to what I did with the condition and selection videos, which is I'm going to present to you with a number of flowcharts, and then we're going to do the Python equivalent of the code for those flowcharts. The first one, which is the one that you're looking at on the screen at the moment, we've actually done the Python code for that already. We did it in video 2, and it's the one where we asked the user to provide us with numbers, which we then created the sum of those numbers and also the average, and we used a loop, a while loop, to continually get or elicit input from the user. The user decided to terminate that iteration with a Q for quit. We will also be looking at something a little bit more complex, which is writing a little game from scratch called Guess the Number. So we will generate a number using the Python random number generator, and then we'll ask the user to guess what that number might be. And to give them clues, we will tell them each time they input a number whether that number is higher or lower than the number that was randomly generated. And of course, that will enable the user to whittle down their guesses to eventually the correct answer, of course. A little bit more complex because we have condition and selection and iteration all in the same Python solution. We'll use this video to go back to basics with the count controlled loop for Python. So we'll ask Python to print out the numbers 0 to 10, and then we'll see how that works from both the Python perspective but also from a flowchart perspective as well. And finally, we will look at another example of a count controlled loop. This time we're going to ask Python to loop through the numbers from 0 to 49, at least to start with. But instead of printing those numbers out, we're going to ask Python to print out the equivalent of FizzBuzz. So if you're not familiar with FizzBuzz, I will cover that in the video at the appropriate point, guys. Okay, so having gone through those flowcharts briefly, let's crack on and do the Python equivalent, the Python code equivalent of those flowcharts. So you may remember from the second iteration video that we created this program from scratch. We set ourselves with a little challenge where we said to write a program to ask the user for positive numbers to add together. The user can stop entering numbers by inputting Q to quit. The program then prints the sum of the numbers to 2 decimal places, and it should also print the average of the numbers. So you saw earlier the flowchart for that. I'm going to pop it back up in a minute. The flowchart doesn't include rounding to 2 decimal places, but the rest of the sequence works fine, and you've got enough there to make a one-to-one comparison with the flow of the code versus the flow of the flowchart. So let me put the flowchart up now, and let's go through the flowchart and see how this works. So we start off with setting or initializing our variables. So that's count equals 0 and total equals 0, or more correctly, I should say we assign the value of 0 to count, of course, and we assign the value of 0 to total. And at that point, we then get our first input from the user. So at this point, the user can choose to enter a number or to queue, to quit by entering the character Q. So we test that condition with the diamond. Has the user input a value which is not Q? So in other words, are we expecting a number? If the answer to that question is yes, in other words, the condition is true, then we have a little bit of work in our calculations to do. If on the other hand, the user has actually entered Q, okay, then we don't progress with the iteration, and we print out the total divided by count, which gives us the average, and of course the total itself. So if the user is inputting numbers, so that's not Q, then total becomes total plus the user input. So we are creating a cumulative total. We increment count, so count equals count plus 1, because we need that to calculate the average. And then, of course, the bit that everybody forgets to do at some point or other, which is to ask the user for their next input, of course. So we ask the user for the next input, and then if you look carefully, you'll see that the arrow, the loop, goes back up to a previous point in the flowchart, and that's the point between get user input and the condition. And of course, we want the next line of code to be testing the condition to see what the user has just input as their next input into the program. And of course, we go round the loop again as long as the user input does not equal Q. So having seen the flowchart, let's compare that with the sequence of our code. So let me put my famous drawing tool back up. So the first thing that we've done in our code is indeed to initialize our variables. So total has been assigned the value of 0, and counter has been assigned the value of 0 as well. So this is the line of code where we are eliciting our first input from the user. So at this point, the user can choose to input Q, so not to iterate at all, or can choose to start inputting some numbers. So this is the equivalent of our diamond. Okay, it's also the equivalent of the beginning of our iteration as well. So we're testing the diamond condition here you saw in the flowchart. Does the user input not equal Q? Okay, so we want that to be true in order for iteration to start. So if the user input does not equal Q, then we're assuming the user is inputting some numbers, and that's when we start to do our little bits of maths. So here, guys, is total equals total, plus of course the cast equivalent of user input, because it's a string. So the same as we saw in the flowchart, basically. We are incrementing counter, so counter becomes counter plus 1, and there's that little line of code, which is the bit which I did joke about in the flowchart, but it's very true actually. It's very easy to forget to put in the bit where we ask for the next user input. So there we go, user input is the same again. Okay, please input a number or Q to quit. So the user has the option again to input a number or to quit. Then the flowchart, if you remember, loops back up to a previous point in the flowchart, and that is the equivalent of us essentially iterating around this block. Okay, so once the user has given us input here, we can then evaluate that straight away at the top of the loop as we go back around the loop. Okay, we are testing again to see if user input does not equal Q. As long as that's true, then we keep iterating, and as soon as that condition is false, then we drop out of the iteration process, and then we have finished iterating, and then we're en route to the bit in the flowchart where we're going down towards stop. So let's just move the code down a little bit. I'll get rid of those boxes. Okay, so finally, our print before the program stops is essentially here. Now, as I said earlier, we did take some liberties with the actual code version because we decided that we were going to round the number to 2 decimal places. But in addition, if you remember, I suggested that it probably wasn't worth doing any printing or calculation unless the user had actually given us some numbers from which to create a total. So if total is greater than 0, then let's actually do some printing of some numbers. If not, there's nothing basically to print. Okay, so although that if statement doesn't appear in the flowchart, okay, you have 99% of the flowchart representing exactly what we have in the code. So this is our little programming challenge, and we are going to solve this programming challenge by designing the solution with the flowchart first, and we will go through the flowchart, and then we will write the Python code that follows the flowchart, and hopefully it should work correctly for us. So let's just go through this little challenge then. So write a guess the number program, generate a random integer from 1 to 50 inclusive. The user continues to enter a number to guess the generated number until they guess correctly. To help the user is told if their number is lower or higher than the generated number. With some good tactics, the user will be able to eventually guess the number. Tell the user how many turns it took them to guess the number. Okay, so let's pop the flowchart up and let's go through the flowchart step by step. So initially we have some variables that we need to initialize. So we initialize count to the value of 1, and then of course we need to initialize a variable to capture the random number that's generated by Python. So that will be num becomes random of 1, 50. So that assigns that random number to the variable num. Next in the flow, we get the guess from the user. So we elicit a user input, and then we need to test the condition. So the condition is, has the user guessed the number correctly? So does guess equal num? If the answer is yes, particularly if it's the very first input, that would be amazing. So if the answer is yes, then it simply prints out well done and the number of turns. Okay, if the answer is no, the user hasn't guessed correctly, then we need to increment count, because that will be the first turn that the user has had guessing the number, and then we need to do that bit where we're helping them out. Okay, so we need a condition to test whether the user's input is less than the generated number. Okay, we don't need to test whether it's equal because we've already done that test earlier on. So we just need to test if guess is less than the generated number. If the answer to that is yes, in other words true, then we tell the user to print, we print higher to tell the user they need to put in a higher guess next time round. If no, then we need to print lower to give the user a clue that they need to guess lower the next time around. Now if you look at the flow of the flowchart, you will see, as usual, we are going back to an earlier part of the flowchart. So that's typical of iteration in a flowchart design, and the place where we want to go back to is the place where the next line in our code would be to get the user input. Okay, so the next guess from the user. And of course, as long as guess equals number is evaluated as false, then that part of the flowchart will continue to loop or iterate until such time as that condition guess equals number becomes false. Iteration stops, and then we're ready to print out well done and the number of turns. Okay, so let's put that design into a practical Python solution. So the first thing we need to do is we need to initialize our variables as per the flowchart. Before that, of course, we need to import the random library, or more specifically, we need to import randit, which is the function that we want from the random Python library. So let's do that now. So let's do from, and then we want random, and then we want to import randit. Okay, and excuse me guys, let's put a comment in that says initialize variables, because that's what we're doing, and then we're going to do count equals 1. Okay, and then num equals, and then we want the actual Python version of what we had in the flowchart, which is randint, and then 1, 50. Okay, so that's our initialization done. So the next bit was we need to create the prompt for the user. So I'm going to put a comment in to say that's what we're going to do. So I'm going to do prompt and get the user input. Okay, so what I'm going to do, because we're iterating and I don't want to produce the same message or prompt to the user each time because they're going to get the message, I'm just going to put what you might call an introductory prompt, if you like, which only pops up once. So I'm going to put in here print, and then we'll say guess the number game. Okay, and then guess a number from 1 to 50 inclusive. Okay, so that'll only pop up once because that's all that's needed really. Now we actually need to assign some input to a variable. So my variable will be guess, just as it was in the flowchart, equals. Now we need to cast the string value, okay, to an integer. So it's going to be wrapped around with int. Then we want the Python function input. Then we want a prompt. So we'll put input number here, followed by my famous 2 arrows and a space. Okay, and then we actually start the game. So I'm going to put in here start the game, assuming of course the user hasn't got the value correct from the outset, because that would be quite a quick and dull game, I suspect. So we're going to start the game, and of course if you look at the flowchart, then we're actually starting the part of the flowchart, which was the iteration. So I'm going to put in here while loop, okay, just to show where we're starting our while loop. And our condition, which is the bit in the diamond, was the, or is the equivalent of while, and then we say guess does not equal, okay, none. Then of course we want our standard syntax and our indentation, and then we want, now we're in the part of the flowchart where we are doing the condition and selection. So that's the precursor to giving the user a prompt. All right, so as long as the user hasn't got it correct already, we do, I'll put in here if block, because this is our if block of code. If block then, and we want if guess is less than num, okay, exactly as it was in the flowchart. Okay, and then we want to say print, okay, that's the clue, and then we want higher. All right, so then we want an else, because there's only two possibilities really, it's either higher or lower. So it's going to be else, okay, and then we want print, and this one will be lower, of course. So lower, exclamation mark. Okay, and then that's the end of our if block. Okay, and if you remember from the flowchart, we need to increment count, okay, because this will now be, essentially we are entering the second guess. Okay, so in readiness for the second guess on this occasion, okay, we will say count becomes count plus 1. Okay, and then of course guys, as I mentioned before, the bit that it's so easy to forget, which of course is prompting the user for the next input. So now, because I've given them all of the instructions beforehand, I'm just going to keep this simple. So next time around, okay, we certainly want to cast an integer, but I'm going to keep the input prompt really simple. All right, I'm just going to put input and then my two arrows as a string, of course. All right, with a space. Excuse me, guys. And then I want integer, okay, and we want a couple of extra brackets there, don't we? There we go. But not like that. So we want int and then input, and then we want input open bracket. Okay, that's better. That's the end of our if block. Okay, sorry, that's the end of our while block. So I'm going to put that over here. End of while block. Okay, so that's all of our code, which incorporates the iteration and the condition and selection. So the only thing I need to write is the print message when the user has eventually guessed the number correctly. So you want to do print, and then we're going to do well done as a string data type, of course. Well done. Right, and then let's do number was, okay. Let's give the user the number so that you know that it was correct. So we want to concatenate, and then we want the string version, okay, or the number cast to a string. And then we want to concatenate. So to make this a full sentence, I'm going to put in with spaces on either side, and then we want to concatenate with the string version of count, okay, which is the number of turns. And then just to finish that sentence off, it's going to be turns at the end of the sentence, okay. Or even turns. There we go. So hopefully that's great. So let's see if this runs correctly. I'm just going to zoom out of there and then move this over so that we can focus on the actual output. There we go. And of course my input. So let's run the program. Okay, so guess the number game. Guess a number from 1 to 50 inclusive. So I'm going to be really tactical, and I'm going to go halfway. So let's do 25. Higher, okay, so sort of between 25 and 50-ish. Let's do 40. There we go. Lower, okay, so what could be between 25 and 40? Let's do 30. Lower still. Gosh, so we've got somewhere between 25 and 30. Let's do 27. Lower still. 26. Yay. Okay, 5 turns, not overly impressive really, but that worked okay. Let's just run it again to make sure it does work properly and it wasn't a fluke. Input number again, so let's do 25. It says higher, so let's do 38. I'm just trying to make it more interesting, guys. Okay, let's do 38. Higher still. Let's do 45. Higher still. gosh. Okay, let's do 47. Higher still. It's going to be 50-50 on this one. Let's do 48. 49. Oh dear, 6 turns. I was a bit unlucky with that one. Okay, where do you get the gist, guys? Okay, now the I guess the message here is that designing your coded solution using something like pseudocode or a flowchart can really save you a lot of time, actually, particularly if it's a complex problem. So we did the flowchart and then we coded the solution directly from the flowchart, and it worked fine. And I suspect if we hadn't done something like a flowchart, or at least mapped out what our solution would be in terms of code structure and sequence, we would have probably made some mistakes in the process of creating our code. So you'll remember earlier on in the video that I put up a very simple flowchart, which was the basic count controlled loop for Python. And what I want to do in this video really is to explore the way that Python works with count controlled loops, which is actually different from other programming languages. And I do think it's worth taking some time out just to show you what the differences are. So the first thing that I'm going to do is, rather than put the flowchart up and actually write some code, is I'm just going to do the pseudocode, particularly the OCR reference language and pseudocode that represents a typical count controlled loop that you would recognize in other languages, particularly languages like Visual Basic, for example. So it would look something like this. So I'm just going to use block commenting just to make this a little bit easier to read. So block commenting is 3 quotes. Okay, and then with the closing quotes we can put anything that we want in the middle. So you may remember from the previous video that we talked about the basic syntax for a count controlled loop, and it looks something like this. So it was for x equals 1 to no, let's do 0 actually, because that make it a comparison easier. So for x equals 0 to 10, okay, and then it was print x, and then we had end 4, okay, or something similar to that. So that's the standard sort of pseudocode reference language version that you would see from OCR. Now, if we ran that code, if that code existed as a proper programming language, and I think it's probably almost the same as Visual Basic, what would we get, do you think, in terms of output? It's obviously a loop. So what is the start and end value for x? Well, actually, in virtually all other programming languages, what you would get from that is a printout where all of the numbers from 0 to 10 are printed inclusive. Okay, so let's now do the version of that loop in Python. All right, so I'm just going to move this up a little bit to give myself a bit more room. I'm just going to zoom out a little bit as well. Okay, so the Python equivalent of this is for x in range. Okay, now I'm just going to put 10 in there to start with. Okay, and then we want the colon at the end, and it's just one line of code in Python because we don't need the end statement, okay, to wrap up the block of code. So it's simply going to be print x. Okay, so let's run that and see what we get. Okay, and you will see on the right hand side that it's actually printed out 0 to 9. Now this is a particular quirk in Python for count controlled loops. Now initially it may seem like a little bit of a pain, and you're probably wondering why Python has to be different. But later on, when we come to look at some more complex code in some of the future videos and in class as well, you'll actually see that this particular approach by Python is actually particularly useful in other circumstances. And I won't go into those in detail because it's off topic. But for the moment, guys, bear with it, okay, because it does make more sense a little bit later on. Now you will see, of course, there's an obvious difference here, but there is another difference as well, because with the let me just bring my box up. Okay, with the pseudocode version, you'll see that here we have a start value and an end value. So we have 0 as our start value and our end value is 10. So that's why we would expect that version of code to print 0 to 10. because we've been explicit about the start number and the end number. Okay, now in Python you'll notice that we don't need a start value in this particular case, and that's because when we just put one number in those brackets there, let me just make it a bit bigger for you guys, sorry, let me get rid of the box and let's just zoom in a little bit. There we go, that's better. So in this basic Python syntax we only have one number in the brackets, and that's because Python assumes if you're not going to be explicit about a start value, it always starts at 0. Okay, later on we'll be looking at other varieties of the syntax where we can be a little bit more explicit, but for the moment we'll just stick with this syntax. Okay, so by default Python starts at 0, but of course you'll notice here that it finishes at 9, and as you may remember that I said previously, with Python, okay, the value that is put in the brackets there means that Python will print up to but not inclusive of that number. Okay, so it will print up to the number -1, which is 9. So of course it has printed out 10, it has iterated 10 times. It's just that this one up here has iterated 11 times specifically to give us 10. But of course Python has iterated 10 times, it's gone from 0 to 9. So obviously with Python, if we wanted to be explicit and say that the last value to be printed out is 10, then of course guys, you will know straight away that we need to actually go one further in our range and specify 11, which means that Python will print up to but not including 11. Okay, so it stops at 10. And just to show you that that does actually work, okay, if we run it now, you will see that Python prints from 0 to 10. There we go. So the question then is, how might we express the particular way that Python works in a flowchart? So I'm going to put the flowchart up now, okay, and then we can see how we can reference that to type of behavior from Python in the flowchart that of course we're using to design our code. Okay, so we need to reflect the way that Python works in our flowchart design. So here's the flowchart, guys, and you can see we obviously start off with start, we initialize count to 0. Okay, so obviously we are representing a loop here, but we can't represent the specifics of a count controlled loop. Okay, we have to represent it in old-fashioned type of iteration terminology. Okay, so we pretend that we're initializing count to 0. The condition that we're actually testing is count less than 11. Okay, so is count less than 11? If the answer is yes, then we print count. Okay, we increment count to count +1. Okay, and we go around until such time as count becomes 11, in which case it is evaluated as false, and then it drops down, and of course the iteration stops. Now, as I mentioned earlier, guys, of course the iteration, the count equals count +1, is actually built into the functionality of the count controlled loop. All right, but we don't have a way of reflecting that in the flowchart. Okay, so if you look at the flowchart, you can actually see that it looks very much as if we're trying to represent a count controlled loop as a while loop, and in fact they are almost exactly the same type of construction. Okay, so whenever you have to represent a count controlled loop in a flowchart, then you have to manually put in the initialization of count equals 0 in this case, and you have to manually put in, okay, incrementing the counter by 1. Okay, so this is the flowchart representation of that very simple Python loop. Okay, so that leaves the last flowchart, which you saw in the introductory part of the video, and I'm going to put this flowchart up now. This is the flowchart that represents the requirement for Python in a count controlled loop to print from 0 to 49, but whenever it comes across a number which could be FizzBuzz or FizzBuzz, it prints that statement out as well. So if you're not familiar with FizzBuzz, basically you take it in turn as a game with a group of people. You go around in a circle. Okay, you go from as high as you can, starting at 0 or 1, and then as you go around the circle counting, if you come to a number that is exactly divisible by 3, you replace the number with fizz and you say fizz. If the number you've come to on your turn is exactly divisible by 5, you will say buzz. And if you get to a number which is exactly divisible by both 3 and 5, then you will say FizzBuzz. And obviously, guys, it gets a little bit more stressful and a little bit more challenging the further on that you count. Okay, so this is the flowchart design for this game. So remember that it's a count controlled loop here. So we start at start, obviously. We initialize count to 0 because we're going to start at 0. And the first thing that we do is we check whether or not we've got to the end of our count controlled loop. So that will be count is less than 50. So that means in Python that will stop when 49 has been evaluated. Okay. All right. So if that's the case, then iteration stops and the program stops. Okay. If, however, we are in between somewhere, between 0 and 49, we need to do some evaluation, some testing. So the first thing that we will do is we will test to see if the number is exactly divisible by 3 and by 5. And one of the reasons that I wanted to put this together as an example is to give you guys some revision of modulus. Okay, so that's integer division and modulus, but also using logical operators as well, because we're going to use the logical operator AND. So you can see in the first diamond, basically the syntax is count mod 3 equates to 0 and count mod 5 equates to 0. Okay, question mark. Okay, so if mod of a number, mod 3 of a number equates to 0, that means that number is exactly divisible by 3. Likewise, a number mod 5 equating to 0 means that that number is exactly divisible by 5. So using a logical operator, we can test if both of those are true. All right, so an example where that would be evaluated as true is the number 15, for example, which is both divisible by exactly 3 and 5. Now, if that is evaluated as true, like 15, for example, it will print out FizzBuzz. If that's not the case, then it will evaluate against the number being exactly divisible by 3 on its own. So that will be the number mod 3 equating to 0. If that is true, it will print out fizz. If that's not true, it will evaluate against 5 on its own. So count mod 5, does that equal 0? If that's true, it will print out buzz. Now, if none of those are true, then it simply prints out the number. Okay, we go back to a previous part in the loop representing iteration in the classic form, of course, and where we go back to is the next iteration of count. Okay, so we go back to the point where the next line in our code would be essentially the next value of count. So you might want to study the flowchart by pausing the video. Now, we've already got to over 30 minutes in this video. My original intention was to actually code this from scratch, so to save some time, I've paused the video and actually created the program in Python for you to study and for us to save a little bit of time. So I'm going to get rid of the flowchart now and then reveal the Python equivalent of that flowchart. Okay, so I've just run it on the right hand side. Okay, and you can see it does indeed. 0 is not correct, but we'll come across that one in a minute. Okay, so starting at 1 then. Okay, if we go through these, 3 gives fizz, which is true. Okay, 5 gives buzz and 6 gives fizz. Okay, all of those are true. We can test 15 because that should be FizzBuzz, which of course it is. The next occurrence of FizzBuzz is at 30, okay, which is exactly divisible by 3 and 5, so that's correct. Okay, and then again at 45. Okay, so we've got a couple of problems with this. The first one is that really we don't want to be starting this game at 0, and ideally we don't really want to be finishing at 49. 50 would be a nice clean place to stop the controlled loop. Okay, so obviously evaluating 0 doesn't give us the correct answer at all. So let's have, before we make some corrections, let's have a look at the code solution and just see how that fits in with the flowchart. Okay, so obviously we don't need to initialize count to 0 in our actual code because that's done for us as part of the for loop. Okay, so that's actually done for us with initialization of 0. Okay, this is our series of evaluations where we're evaluating using the Python modulus, which is the percentage sign. Okay, so this block of code is where we're doing all of our if, elif and else conditions to see if it is divisible by both 3 and 5, or 5 on its own, or 3 on its own. The default position, of course, is it must just be the number. Sorry, that's not the default position. The default position is here, okay, where it must just be the number, so you print out the string version of the number. Okay, so that big block of condition and selection is essentially the heart of the iteration as well. So I put in here, that's the end of the if block, and of course there isn't anything else to do because we've done our printing within the code itself. So that's all we really need to do, and it does work correctly, and it does actually follow the design in our flowchart. The problem is, as you can see here, we don't get a sensible evaluation when count equals 0. So we really want to start when count equals 1. And the question is, how might we do that? So the way that we do that in our Python code is, rather than allowing Python to default to 0, we need to be explicit about what the starting value is. And it's very easy to do that actually. All we do is we just pop in the starting value as a figure before the end value. Okay, so it's 1, 50. And of course, as you know by now, guys, Python is a bit quirky with up to but not including the last value in the range. So we need to increase that to 51. Okay, so that basically means that Python will evaluate a range starting at 1 up to but not including 51. So that basically means it will stop at the point where 50 has been evaluated. So if we run our code now and see what we get. Okay, so let's just get rid of the box. Let's go up to the top. Okay, so this looks a lot more healthy. We've started at 1, okay, which is exactly what we needed, and we've got a sensible first evaluation of just 1. Okay, and then of course the rest of the code is correct as you might expect. And if we go right to the end, we can see that actually indeed Python does loop up to but not including 51, so it stops at the point where 50 has been evaluated as the final test or the final condition. So guys, if you did want to study the flowchart and study the code solution in a little bit more detail, then obviously rewind the video a little bit and pause where you need to. Okay guys, so that wraps up this video. We've covered a lot of ground in this video, but in the next video we will be looking at the Python count controlled loop in a little bit more detail, and I'll be telling you some more things which OCR requires you to know about when it comes to count controlled loops for your GCSE computer science, guys. So I will see you in the next video.